Okay, now that you've had a little bit of time to work on this, hopefully we can just kind of look through this quickly. The first 6 obviously was where the work was. You had to look at these and justify each step as you worked through them. A couple of them might have been, a little bit new, that you kind of didn't realize, well, this maybe I have to do this one just a little bit differently. And then the 6 after that, just real basic true and false. And so I want to make sure that everybody understands all of these and we're kind of on the same page when it comes to this stuff. Okay, so first, let's take a look at number 1. Well, it says 3x minus 40 is one of the angles, 2x minus 10 is the other angle. If I look at these, those are vertical angles, so I can set those two things equal to each other and say that 3x minus 40 is equal to 2x minus 10, and the reason why is because vertical angles are congruent. Okay, then I go ahead and maybe subtract 3x from both sides, and I'm left with negative 40 is equal to negative 1x minus 10, and that would be the subtraction property of equality because I just subtracted from both sides. Go ahead and add 10 to both sides. That would give me negative 30 is equal to negative 1x, and that's the addition property of equality. And then go ahead and divide both sides by negative 1 or multiply both sides by negative 1. Either way, I'll get 30 is equal to x, which would either be the multiplication or division, depending on how you did it. Property of equality. And lastly, we could spin that around and say, well, then we know that x is equal to 30, and that's because the symmetric property of equality says you can spin things around the equal sign. And so we get that x is 30, and we're done. If you went the step above and beyond, it didn't ask for it in the directions, but if you went for the step above and beyond to plug that back in, you'd go, well, then I know that 3 times 30 minus 40. And 3 times 30 is 90. Minus 40, so 90 minus 40 is 50 degrees. So that angle right there is 50 degrees. You can double check, make sure you're right by doing it with the other one and saying, well, 2 times 30 minus 10, 2 times 30 is 60, minus 10 is 50. And again, we've got the same answer here and here. So math is true. All right, moving on, because I know that you've already done this kind of thing, so you should be able to do these pretty quick. On number 2, we don't set it up by saying these are equal to each other, but some of you probably did that. Instead of saying 6y minus 10 is equal to 6y plus 10, we say 6y minus 10 plus 6y plus 10 is equal to, well, these two angles put together are what's called a linear pair. They're two angles that back up to each other and create a straight line, okay? So that means the two of them must be supplementary and they sum 180. So I can say, well, these two angles add up to be 180. And, if you had to justify why, you give a couple of reasons. You say, well, that's because they're a linear pair. You could say they're supplementary angles. However you want to justify that one. Okay? At that point, then what I do is I'd combine like terms. 6y and 6y gives me 12y. Negative 10 and positive 10 actually cancel out, and so I'm left with just 12y equals 180, and that was just simplifying. Divide both sides by 12, and y is equal to 15. That's the division property of equality. Okay? If I plug that back in, I go, well, 6 times 15 minus 10. 6 times 15 is 90, minus 10 is 80. On this side, I'd go 6 times 15 plus 10. 6 times 15 is 90, plus 10 is 100. And those two answers make sense because if we have 80 on one side, 100 on the other side, the total would be 180. All right, number 3. This has a symbol that we have not directly talked about, but I know all of you have seen before. This symbol right here means right angle. That means 90 degrees, okay? So that means that this side right here is 90 degrees. Now, hopefully you can just basically reason that if this side, this angle over here is 90 degrees, and the two of them must add up to be 180, then everything over here would also have to be 90 degrees. So really, you could start this one out one of two ways. You could have either said 90 plus 4z minus 10 plus z. See, I've got 3 angles going on there. I've got one right here, one right here, and one right here. So I got the 90, the 4z minus 10, and the z. There's my 3 angles. And I would say that all of those add up to be 180. And I could say that it's because they are supplementary angles. Now, maybe you did that. Or maybe you kind of skipped ahead and said, well, I know that these two over here have to add up to be 90 if this one's 90 over here. And so maybe you just added them up and said, well, 4z minus 10 plus z equals 90. And that would be totally okay as well. And I could say that because, they're complementary angles. Complementary angles is something we didn't talk about yesterday, but I know it's something you've heard in the past. Complementary angles they are not angles that just talk nicely about each other, but complementary angles are angles that sum 90 degrees. Supplementary angles are angles that sum or add up to be 180, but complementary angles are angles that sum 90. And so that's what we have here. So either you wrote this whole thing, and you said, well, those are supplementary angles, and then the trick would have been to get from here to here, it would have been subtraction property equality. Because you subtract the 90 from here, you subtract the 90 from here. It's no longer on this side over here, and then the 180 went down to 90. So if you did start with this very first step, then you'd say your second justification would be the subtraction property equality. Or maybe you started with the second step. And what would be your reason? Well, because complementary angles. That's what those are. Those are complementary angles right there. And now we just go ahead and simplify. 4z and z would give me 5z minus 10 is equal to 90. And so that is what all we did was there, simplify. Okay, add 10 to both sides, you get 5z is equal to 100. And that would be, all I did was do the addition property of equality. And then go ahead and divide by 5. And z has got to equal 20. Not necessarily 20 degrees, but 20. Somehow I ended up with it. All right, it's 20. And so that would be the division property of equality. And so I can take that and I can plug that back in, realizing that that would mean that this part right here is 20, and this one, 4 times 20 minus 10 would give me 80 minus 10, so that would be 70 right here. So I've got 20 on the bottom part, 70 on the top part, and the two of those add up to be 90, so that makes sense. All right, number 4, very similar, almost the exact same problem. I've got 90 on this side, so I must have 90 on this side. I'm okay with those same two ways of doing it, but I think most of you would probably go, well, 9x plus 4 plus 32 all must add up to be 90. And why? Because they're complementary angles. Go ahead and simplify. You get 9x plus what? 36 is equal to 90. And all I did right there was simplify. Subtract 36 from both sides, you get 9x is equal to, now 90 minus 36 is 54. And so that was the subtraction property of equality. And go ahead and divide by 9, and that gives me x is equal to 6. There we go. And that was the division property of equality. I take that 6 and I plug that back in, and I would get 9 times 6 plus 4, and 9 times 6 is 54, plus 4 would give me 58. And I go, does that make sense for this one to be 58? Sure, because this other one is 32, and 32 and 58 gives me that 90 degrees. All right, number 5, there's 2 different ways you could have done. There's an easier way, and there's the really easy way. So easy way is to go do exactly what we've talked about before, and say that 4x plus 1 plus 7x plus 3 is equal to 180. And why is that true? Well, because those two are supplementary angles, or they're a linear pair. Simplify, and you get 11x plus 4 is equal to 180. And now all we did with it there was simplify. Then go ahead and subtract 4 from both sides. You get 11x is equal to 176. So that's the subtraction property of equality. And divide both sides by 11, you get x is equal to 16. So that's the division property of equality. All right, so that's one way you could do that problem. The other way, which would be look completely different, is you could say, well, I know that this angle and this angle are vertical angles. So this is the really, really easy way. You could have said, well, therefore 4x plus 1 has got to equal 65, and that's true. Okay, and that would be because vertical angles are congruent. You should always know why something is true. So therefore 4x is equal to 64, because I subtracted 1 from both sides. And then I would know that x is equal to 16 because I divided both sides by 4. And so therefore the division property of equality would say x is equal to 16. I could plug that back in and say 4 times 16 plus 1. And therefore that would have to be 64 plus 1, which means this is 65. Surprise, surprise. No, because this side is 65, they're vertical angles. And then I could plug that into the other one, say 7 times 16 plus 3. 7 times 16 would be 112. 112 plus 3 would be 115. And does that make sense for this angle? Of course it does. Because 65 and 115 add up to be 180. Okay, so that makes sense. And lastly, number 6. Okay, we got a couple reasons that we kind of know this here, but this up here is 90. So that would mean that this all right here has to be 90. And so therefore we could say that 4y plus 6y is equal to 90. And you really kind of almost have 2 reasons. It's because, we've kind of got complementary angles, and also because vertical angles are congruent. Because we're saying, hey, this clearly is congruent to this part over here. All right, I simplify and I get that 10y is equal to 90. That was just a little simplifying there. And then divide. Y is equal to 9. So that's the division property of equality. And there you go. Plug that back in. You get 4 times 9 gives me 36. So that's what this angle is right here. 6 times 9, you get 54. So that's what this angle is right here. 36 and 54. All right. And now we got this last 6 to talk about these true and false. Hopefully you looked at these and every single one of them, you just were like, oh, I'm positive on that one. I know this. That's where I'm hoping you landed. Okay. Angles 1 and 2 are vertical angles. Is that true? False. You know that. Vertical angles are always opposite of each other. So that would be like 1 and 3 or 2 and 4. But 1 and 2 are not vertical angles. Number 8, angles 2 and 3 are supplementary. True. Okay. Angles 2 and 3 are clearly a linear pair, so they are supplementary. All right. Number 9, the measure of angle 1 is equal to the measure of angle 3. True, okay? Angle 1 and angle 3 are vertical angles, which means they're congruent. And if they're congruent, this is the definition of congruence. They have the same measure. Number 10, measure of angle 3 plus the measure of angle 4 equals 180. True. Angles 3 and 4 are a linear pair. They're supplementary angles, and this is the definition of supplementary angles, that the two of them would add up to be 180. Number 11, measure of angle 1 plus the measure of angle 3 equals 180. False. Now, it's possible that the two of them add up to be 180 because this angle right here could be a 90-degree angle. This one could be a 90. A 90 plus 90 would give me 180. But there's nothing that I know for certain, and they don't even look like 90-degree angles. So I can't be certain about that at all. And lastly, angles 4 and angle 2 are adjacent. What is that one? That one is false. Adjacent angles are two angles that have a common side and a common vertex. They kind of back up to each other. Whether they create a straight line or not, it doesn't matter. Adjacent just means alongside of or next to. And clearly, angles 2 and 4 are not alongside of or next to each other. All right, I hope you got all of those right and these made sense and I filled in any blanks that you were uncertain about. You guys have a great rest of the day. Get ready to learn a little bit more.